when it cuts off, it zooms out, and it's kind of cantankerous on zooming in. All right, quiet please. Here we go. 4.3, inverse of functions. The first thing that you need to understand, here's a very simple T-chart. -2, -1, 0, 1, and 2. And I'm just going to come up with numbers 5, 6, 7, 8, and 9. Okay, that is a T-chart of some imaginary function. If I were to find the inverse of that function, then all that happens is the domain and the range are swapped. Okay? So the inverse of that function is here. 5, 6, 7, 8, and 9. -2, -1, 0, 1, and 2. The inverse of a function is simply where you swap the domain and the range. Those values are swapped. Notice my notation. This kind of looks like x to the -1 or y to the -1. That's not what it is. Unfortunately, it looks like that, but the way we read that is either x prime or y prime. That's how it's read. It is the inverse. Questions? There'll be problems like this on the test. Tell me the inverse range, or tell me the inverse domain. And all you have to do is be smart enough to know domain and range, and then be smart enough to flip-flop it. Okay, the x's become y's, the y's become x's. If I were to graph these points and then graph the inverse, they would be flip-flopped around a line called the x, or the y equals x line. This line here is the line that they're flip-flopped about. We don't do much graphing, so that's not very, I just wanted to explain that. If we were to graph these points and then graph these, they would be flipped around this line. This is kind of the center line. It is the y equals x line. It would be flip-flopped around that line. Questions? All right, so now how are we going to use this? How are we going to have some more problems? Because obviously those are too easy. Well, the first type problem is going to say y equals x plus 1. Right, there's a function. It might say f of x equals x plus 1. Either way, f of x and y are the same thing. Okay, that's a very simple function. We could graph it. Right, the y-intercept's 1, the slope's 1 over 1, has a positive slope. We could graph it very easily. If I ask you to find the inverse of that function, okay, the first step is very simply to swap the x and the y. Wherever there's an x, you put a y. Wherever there's a y, you put an x. You flip-flop the x and the y. Then, all you have to do is solve for your new y. Okay, if I got y plus 1 and I want to get y by itself, I simply subtract 1 from both sides. So y prime is equal to x minus 1. I have to put the y prime on there so you know the difference between y and the inverse of y. Does that make sense? This y is the function. This is the inverse. Okay, so the inverse is down here. Y prime is equal to x minus 1. If I did a T-chart here and I did a T-chart here, the x's and y's would be totally flip-flopped. Okay, questions? Any questions? All right, let's do another example. You're here to... Sit right there. What number are you? What number are you?
17.
Do you remember if you had version A or B?
Do you want me to cut off the video?
No, just let it run. We're almost there. Ready to get all these finished. That's what I've been working on at lunch. All right, here you go. All right, here we go. Let's do another example. A little harder. Y equals 2x minus 3. Y equals 2x minus 3. What's your first step? Swap the x and y. So you put an x here, and you put a y there. Okay, piece of cake. You can put y prime there. You can go ahead and start putting that little -1 up there. to me it gets confusing. I know that that's my y prime. I don't like putting it down here until the end. Okay? You can put it there just to denote that that's y prime. It's up to you. Okay? Now, I add 3 to both sides. I'm going to write the 2y over here is equal to x plus 3. Okay, now what?
Divide by 2.
Divide both sides by positive 2. So divide here and I divide here. Y equals 1/2 x plus 3 over 2. 1/2 x plus 3 over 2. How did I get this answer, or why did I get this answer rather than what's inside the box? Why is the book going to break it up like that? Why is this a better answer? Because it's in slope-intercept form, exactly right. Because this is in slope-intercept form, I now can easily see the slope and I can easily see the y-intercept. So if I were to have to graph, i.e. next year, okay, if you were to graph, then you're already in slope-intercept form, you're ready to graph. I probably will accept that. But I want you to know that your book is going to break it up and look like this. If that 3 were a 4, then they'd have a 2 out here, and I don't want you to see a 2 and go, where'd that come from? Kyle?
On the y, do we still need the
Yes. I would put the -1 there for y prime. Thank you. Anybody have a question? Anybody have a question? All right, how much time we got left?
We added the 3.
Uh-huh.
I ain't got all of it. 640.
Okay.
On x equals 2y minus,
Not
and you
you.
add 3 on both sides. How do we get the 2y?
2y. I just wrote it on the left because I like my y's on the left. I just wrote it on the left. I wrote the x plus 3 on the other side. All right, I'll write it here. Y equals x squared. Unfortunately, they like to put some of these in there. Well, actually, we'll do y squared and then we'll do y cubed. Or x squared and then x cubed. Okay, first step is to do what? Swap them around. So I got x equals y squared. Now what do we need to do? Square root both sides. So I square root the left and I square root the right. What do I need to remember though? Plus or minus x. Plus or minus. You square root both sides, you need to remember the plus or minus. Okay? Questions? What if the exact same problem, what if I have x cubed? Because you've never solved one like this before. This is new for you. This is a new concept. If I have x cubed, right, and I flip-flop them, and I'm to there, how do I get rid of, here I square rooted both sides. What am I going to do here to get rid of the 3? Anybody have an idea? There you go, Jimmy, say it again.
Cube root.
You're going to cube root both sides. What does that look like? Well, did you guess? Was that a guess, or have you heard that before? You're going to cube root both sides, and when you cube root, it looks just like a square root, except for you write a 3 right there. You're doing the cube root. It's kind of the opposite of cubing something. If square root is the opposite of squaring something, then cube root is the opposite of cubing something. So y prime in this case would simply equal what? The cube root of x. Do we have to worry about a plus or minus? No, we do not. Why not? Because it's odd. Because it's odd. What if I did the 4th root of both sides? Would I have to worry about it then?
Yes.
Yes. If I did the 10th root, would I put plus or minus? Yes. But not the 9th root. Because it's odd, right? And when I take say -3, and I cube it, I still get a negative number. Okay? It's kind of confusing. I know you had never done that before, but I wanted to show you at least one. All right, let's get our workbook out and turn to page 129. Workbook, page 129.